Welcome to Tecversity. This is Venkatesh Nataraj. Today I'm going to talk about memory. Memory of computer. There are two things we have to talk about. One is the memory and the binary. The binary language which computer understands. These two are interconnected. We cannot separate these two topics since the memory is stored in the computer in binary language and computer can understand only the binary language. Now, when we try to send a message to our friends, it could be a simple SMS or an email or WhatsApp or a LinkedIn messenger or a Facebook, whatever the messenger that we are trying. We use whatever the terms that we use, including the emojis, the message with the capitals. It will go exactly the same way to the other person. There will not be any change. And how exactly that happens? Because the data what we are trying to send will be converted into a binary language, and that binary language will be transmitted over the network and it will reach to the destination, and again it will turn into the characters. So to understand better, I'll explain in this video how exactly the memory will be calculated and what is this binary is all about. In general, the binary language is the computer language. That means when we say something for the computer to do a specific task, we have to inform the computer to do it in binary language. That means our task, whatever we are saying, it should be in our human language, but there is an interpreter which will turn our task, our communication into binary language, and it will inform the computer to do that specific task. I know it sounds a little difficult to understand, but in this video, believe me, I'm going to explain in detail about all this. For example, we went to a store and we want to buy a computer or a phone. Two primary factors what we look is what's the memory size. When we are trying to store the data, because since it's a phone, we try to capture moments like photos, videos, documents. So we'll try to see what is the memory. And then we also look at the RAM. What is the RAM? How much is the RAM? Of course, there is something called a processor, which is very extremely important. That is a separate topic, but purely I'm concentrating on this. And same thing with computer or a laptop. What is the memory? Like we say hard drive size, and then we'll talk about the RAM size. Now these two are very important to understand how much is the data we want to store, because we think of buying a 1 terabyte of data and we'll think, okay, this seems to be a good enough, we can store huge data. And what is that huge means? How exactly a photo or a character or a movie or a image will turn into memory, turn into data, and it will be stored inside the hard drive. In this video, we will understand that. At the same time, this entire conversion will happen at a binary language. That means even you want to store a notepad with 1000 characters, that will be stored in binary language. And if you want to store your favorite show or a movie or a clip or a photo, even that will be stored in binary language. That means by the end of the day, the computer can understand only one language, that's binary language. That means 0 or 1. So in this video, we're gonna cover both, about memory as well as binary language. To get a better picture, I will start with the binary language, how exactly this binary language a computer will understand, how this entire conversion happens, like from zeros to ones, and what exactly the computer understands. So we'll start with the binary and move towards the memory. This is going to be an engaging video, so make sure you subscribe to this channel Tecversity and share this video with your friends and family, and don't forget to click on bell icon. Let's jump into memory and binary. To understand how exactly the memory evolved over the period, like from the first computer till date, if you observe, there's a huge change in the way that we manage the data. Now the first computer has only 4 kilobytes of space. Remember, it's only 4 KB. And the first smartphone, which is a Simon, which was introduced in 1994, has 1 MB of RAM and 1 MB of storage. And today we can't even assume when we have 4 GB of RAM. For RAM, for a smartphone, if there is a 4 GB, that means it's pretty slow, because the memory and the kind of smartphone or the computers have been evolved over the period, and the kind of data that we consume on a day-to-day is extremely more. So in this video, I'm going to explain how exactly the binary functions. That means first let's understand how exactly the data is converted into binary language. That means a 0 or 1. The first thing, remember, when I refer to binary, that means a 0 or 1. That means a plus or a minus. In general, you can also refer to the plus or minus, where the plus refers to 1 and minus refers to 0. So this is the basic of computer memory. Now, if you remember the olden days, we used to have something called analog signals. The analog signals are something like this, the way kind of a waves, where when the signal comes up, it is a plus, which is also referred as 1, and when it comes to the down, that means a minus, and it is also considered as 0. So everywhere, whether we are in analog era or a digital era, this is the standard. So we are going to talk about ones and zeros. Now let me explain what is ASCII. To start with the memory, we have to understand what is ASCII is all about. American Standard Code for Information Interchange. So that is the first organization which finalized the characters. Like I mentioned in the intro, I said, right? So when we send a message to someone, to your friend, hey, come to this park to meet. Now when you mention an exclamation or a smiley or a capital letter or a small letter or some additional changes in that particular wording, it will go exactly the same way from your phone or from your computer to the recipient. There is no change in it. That happens because the ASCII is the key factor that plays. Now what exactly ASCII is? American Standard Code for Information Interchange. That means every character will turn into zeros and ones. For example, I will give the description. In the description, you can have the link to ASCII chart, where you can see the number of characters and how each character will turn into zeros and ones. Now every character will have a ASCII value in decimal. For example, capital A, let's start with a capital A. Now capital A is 65. This is a ASCII value. That means in a decimal value, computer will understand when you type A. So we all know about the LCM, which is the least common multiplier. So this 65 will turn into zeros and ones by using the LCM, like 65 0. By default we can take it as 0, and then 65 2, it will be 32. Since 65, it will be 32 into 2 is 64, so there is a 1, and then 32, 16, 0, 8, 0, 4, 0, and then 2, 0, and then 1, 0. Hope it's clearly visible, right? So now we have to calculate this ones and 0, whatever the combination that we received from the bottom. So it will be like 1 0 0 0, that is here, 0 0 1 0. So see, now we got a 8 character number, 100, okay, 100 0 0 0 1 0. See, 4 and 4, it's total 8. So every character in the memory will turn into 8 numbers. That means, let me explain once again. So every character, like I mentioned about the 65, when ASCII has mentioned A equal to 65. So 65, when we do LCM, it will form in this way. So we have ended up with 8 characters, 1 0 0 0 0 0 1 0. Now each character of this is 1 bit. So when I say 1 or 0, that means either 1 or 0 will be considered as 1 bit. Now 8 bits equal to 1 byte. Now we all talk about the memory, right? Say 64 GB, 34 GB, 32 GB or 8 GB, 2 TB, 1 TB. So how exactly this happens is, this is how it calculates. So one character of anything will turn into 8 bits, and that happens like this. I'm talking about character, not the full name. For example, if my name, if you want to turn it Venki into digital data, like into binary, every character, V will have a ASCII value, E will have ASCII value, N will have ASCII value, K and Y also will have an ASCII value. So each character will turn into 8 bits, and it's a combination of zeros and ones, like how we have seen it here. For example, let's see how exactly it is for V. Now V has 66. 66 is the ASCII value. So 66 0, it will be 33 0, and then 33 in the sense it will be 16 1, since 16 into 2 is 32, and since we have 1 extra, it will come here 1, and then 8 0 4 0 2 0 1 0. So similarly 1 0 0 0 0 1 0 0. So this is the capital B ASCII binary value. So let me erase this for better clear. So this value, now if you see for capital A it's a different, capital B is different. Similarly for every character, this ASCII will turn that into zeros and ones, and that's how the data is stored. So like I mentioned, for my name, if it is Venki, it needs 5 bytes. Now let me explain about how memory is calculated. Now you understand how ASCII value is, and for every ASCII, I'm going to share in the description the ASCII chat, so you can refer to that chat to understand how that characterize for each character what is the number, and you can do your own math at your home to understand what's the binary value for each character. Now let's try to understand this memory. Now we have seen one character is having 8 bits. One character will have character, whether it is a capital A or B or comma or space or at the rate or equal to, whatever, even including the inverted commas, exclamations, smileys, everything is considered as one character, and that will have one ASCII value, and that will turn into zeros and ones. Now one character equal to either 8 bits. Now let's understand how this works. Now 1 bit equal to, we have seen either 0 or 1. Now 8 bits equal to 1 byte. Remember, it is 1 byte, and 1024 bytes. 1024 bytes equal to 1 kilobyte, which is also referred as KB. 1024 bytes, 1 bit equal to 0 or 1, 8 bits equal to 1 byte, and when we say 1 character, that means it is a 1 byte. When I refer my name as Venki, that means it is having 5 characters, that means 5 bytes. So just the name of called Venki will have 5 bytes. Think if it is your name, if it is 15 characters or 16 characters, how many bytes it will require and how many bits it will convert into. Now and then 1 byte is 8 bits, and 1024 bytes equal to 1 kilobyte, and 1024 kilobytes equal to 1 megabyte. 1 megabyte, which is also referred as MB. I'm sorry about the handwriting. My handwriting is very poor. Hope this is very clear. In case if it is not clear, please comment. Give me the comment. I will try to improve my handwriting. But I'm sorry about that. And 1024 megabytes equal to 1 gigabyte, which is also known as GB. So this is where we say I have a phone which has 8 GB of RAM, 4 GB of RAM, 64 GB. So that means it has, each GB has 1024 megabytes, and 1024 megabytes means, think when we do the reverse mathematics, think how many characters it can fit into it. And remember, everything including the colors, images, photos, documents, whatever it is you're storing in the computer, it will be turned into zeros and ones. You may be thinking, hey, for characters, ASCII has given these values. How exactly the color? So even that, it has a other values that we will be discussing in the next video about how the RGB, that means red, green, blue colors, will turn into memory, and how memory will understand this is what for this color. In that case, it is not just only the binary. It, of course, it's stored in binary, but the conversion happens at a hexadecimal. Now after 0 to 9, then the 10 will be calculated as EA. Since it's a hexadecimal, that's purely a different topic. I will be talking about that in separate video. So for now, you understand this is how it is. Now 1024 megabytes is 1 byte, 1 GB, and then 1024 GB is 1 terabyte. Now nowadays we are seeing 1 terabyte even available on a small memory card. So from the huge sizes of data storage containers, now it has come to a tiny memory card which is capable of holding up to 2 terabyte or 1 terabyte, and going forward it's going to be huge. And the next, since the AI is playing a crucial role, now the technology is advancing every day pretty fastly. So no wonder we will see even the 1 petabyte, like 1024 terabytes is equal to 1 petabyte. Even that we will see in a small size of memory card in next few years. And we don't know, it could happen in the next year itself, or it may take some more years. But that's how the advancement in the technology and the storage devices are getting evolved. So pretty much this is about the memory. So I hope you get a fair understanding about how exactly the memory is calculated. And when you purchase a device or a storage device like a pen drive or a hard drive or a phone, you understand now, okay, how much it is really capable of holding into it. So this is about it. Now we will talk about since the memory is converted. So I have explained two topics here, the binary and the memory, because these two are interrelated. We cannot separate the binary and we cannot separate the memory. These two are interrelated. That's the reason I have explained about the usage of how the characters will turn into memory when we say the memory calculation, and how the data is turned into binary. Everything covered in this video. If you have any questions, please feel free to drop comments and go to the description section and review all the documents and the links. That will, all the links will have separate documents. Go and review it. It has so much of information, and give your valuable comments. And also make sure you subscribe to tecversity and ensure that click on the bell icon for the future notifications on the next videos. Have a good day, and I'll ensure all the next upcoming videos are also engaging. Have a good day. Bye. Take care.